Hey, good afternoon. My name is Kahou, and I'm a principal software engineer in Off-CO platform at Okta.
Hi, I'm Jeremy, and I'm a staff engineer with the Auth0 platform at Okta. And today we will go over our usage of Argo CD and Argo Workflow within our platform. First, we will go through our platform history and our design. Then we will do a deep dive on Argo CD, then Argo Workflows, and then we'll have a few minutes left for a Q&A. So first, we will go over the platform history and how we got to our current design. In its first iteration, the platform was mainly a way to host Auth0 services for customers who wanted their infra and configuration stored in a private cloud account. It was targeted for a very small subset of customers, and as a result, was not built with high scale and automation as priorities. It had Snowflake config and infra. The updates were done manually by an operator. Access was not as secure as it could be. And it was using early days cloud infra, so basically code running in VMs. With our private cloud solution becoming more successful and requested, we had to quickly iterate on a new platform that could cover the increasing demand. After a few months of research and proof of concept, we ended up on this design. So it leverages a lot of cloud-native technologies with a highlight on Argo project, with Argo CD used for the service provisioning, Argo Workflows for the deployments, Terraform with a provider that we maintain for all the infra as code. And these are all orchestrated by control plane services. So with all of these, we can manage all the customer environments.
So thanks, Jeremy, to introduce our control plane platform. So as you can see, right, from the previous slides, we use a lot of Argo components to drive our deployment pipeline, and they are the core component. So the next question is we will ask why we want to use Argo. So, and it comes with a lot of reasons. So the first reason is that they are very easy to install in use. Whenever we have a POC, we just install them locally so that we can iterate the POC much faster. Also, Argo CD provides a very flexible, customized integration. So it even allows us to control our different customized plugin version onto different customer development environment. So also, Argo Workflow is very flexible. So basically, we can plug and play different Argo Workflow steps and come up with different deployment model. And they have very good API and CI integration. So right now, we can fully integrate this API client into our control plane business logic. And also, Argo CD and Argo Workflow has very good dependency model, such that the Argo CD has the sync wave that can control different servers, different servers apply order, and also Argo Workflow provide a very complicated dependency control so that we can deal with different deployment situation. And also, last but not least, they both have a very strong open source community. So before we deep dive into how we use Argo CD, so let me give you some numbers. So right now we have around 1,000 to 2,000 Argo CD applications. And among all of them, we have 2 to 3 million resources, Kubernetes resources that we to manage. And we have around 32 Argo CD application controller pod, and then 24 repo server pod, and then X server pod to control everything. And overall, we only have one instance. That means we only have one install, one control plane to drive all our deployment pipeline. So the first item that I want to discuss is the Argo CD auto sync. So for those who doesn't know what this feature is, basically it's a very powerful feature such that we ensure that the application in the Kubernetes cluster always mirror what we have in our Git repo. So it gives us a lot of benefit, right? So the first thing is that it always do the reconciliation. So that means that if someone go to the target cluster, manually change something in the target cluster, Argo CD auto sync will just automatically reconcile back from what we have in the Git repo. Also, it follows the Git ops principle. That means that all the source of truth is from the Git repo. So combining both of them, right, it always gives us a continuous deployment. So that means that if someone push change to the gig repo, it always automatically reflects like on the target cluster. However, we cannot use these auto-sync features in our deployment pipeline. The reason is that like, it depends on our release model. So our release candidate is basically a bundle of our software stack, which include all of our microservice image version, all the Terraform code, Kubernetes manifest, Terraform, homegrown Terraform plugin, and homegrown Kustomize plugin. And we bundle everything and call it as a release manifest. So right now, we always use one release manifest to represent our Argo application version. And also, we only have one Argo application to represent one cluster. So that means that at a certain point of our deployment, we have 2,000 Kubernetes clusters to manage. And the most important thing is that like, a lot of configuration and secret that the microservice use depends on like, how we run the infrastructure, which is a Terraform. So how it works is that way, like we always run our Terraform plan and apply first, and then like, our homegrown Terraform plugin will grab all the information from different cloud resources or like from other area so that you can save the configuration and secret in our control plane database. Later on, when we kick off the Argo CD sync, our homegrown Kustomize plugin will grab all those resources and generate a giant config map, secret, and also all the resource manifest and apply to the target cluster. So that means that like, if we just use the out-of-box Argo CD sync, right? So it will miss all the Terraform change, and a lot of servers will not come up like correctly. And then another most important thing is that like, we have a customized deploys window. That means that like, we cannot always like, turn on the auto-sync. We have the agreement with the customer that like, at a certain point of time, we can only like, upgrade their cluster at that time. Other than that, like, we cannot like, push code to their environment. So with this use case, we cannot use the Argo CD sync. We have to implement our Argo CD sync. So from the right side of the diagram, you can see that like, the control plane basically has a scheduler and also has a deploy manager. So what that does is that like, when the deploy window open for the customer, the scheduler will just grab the eligible release manifest, and then like, it will pass it along all the tasks to the deploy manager. And then the deploy manager will submit a Argo workflow. What the workflow does is that it has like, a couple major steps. So the first step is that like, it will just like, run the P5 check. The P5 check include that like, it will make sure that the release is eligible. We have a healthy cluster. And once all the P5 check is done, right, the next step in the Argo workflow will just like, do the Terraform plan and apply. That comes along with our plugin, and that will gather all the configuration and secret and save it into our control plane database. And then later on the workflow, it will kick off the Argo CD sync. And the Argo CD sync will also rely on our homegrown plugin that will generate the config map and secret and also the resources and apply to the target cluster. So this model is complicated, but it gives us a lot of like, benefit. The first thing is that like, it has a better control. Like over the year, like, we see a lot of like, transient error on the Argo CD sync. So with this, right, we can totally control the retry count in the workflow, and also we have a special script to wrap around the Argo CD sync to make sure that our Argo CD sync always runs smoothly. And also, like, it has a flexible priority because like, it reduces the burst radius of how we upgrade on the customer environment. So let's say like, we have like, a customer has like, a development environment and a production environment. Our deployment manager can always control that like, it always land the release to the development environment first. When everything is done, right, we can just move it to the production environment. And another thing is that like I mentioned, like we have 2,000 Argo CD applications. So if we just use the upstream auto-sync, I'm pretty sure that they will crash all the Argo CD components. So with our scheduler, we can just totally control like the upgrade into different patches so that we can make sure that the Argo CD component always up and running.
Thank you. Yeah, so the scale we operate at is quite big, and we have a lot of services that are deployed with the platform, and we have new services that are added regularly. So it means that the platform team cannot own the implementation of all the manifests for all the services. On the other hand, we cannot expect the service owners to know Kubernetes and to be able to follow all the best practices we have. And so to fix that, like we mentioned, we have the Homegrown Kustomize plugin. So we call it the Application X plugin. And from a dev perspective, it means that they just need to know which type of application they are deploying. So is it a cron job? Is it a web service or a worker? And typically then they have to write about 60 lines of YAML manifest, not including the config and secrets. And the generator from that file will be able to generate all the Kubernetes resources, so the config map, the secrets, the deployment and services, etc. And all of that through conforming to all the security best practices we have, and as well as all the auto-scaling properties. But we did run into a small issue with that pattern, so mainly due to performance and how Kustomize handle plugins. So the way Kustomize does plugins is that it does exec in a subprocess. And so since most of our manifests were plugins and we have hundreds of them, it would cause the refresh from Argo CD sync perspective to take minutes, because Kustomize would have to spawn hundreds of subprocesses. And so to fix that, we actually forked Kustomize, and we built in the Kustomize binary directly all the plugins that we have. And that way, Kustomize can execute all those plugins directly in the same process. And this brought down our refresh from a few minutes to just a few seconds. It still left us with one Kustomize challenge, mainly due to the fact that all customers have different versions. And so we cannot allow the version of the Argo CD Kustomize plugin that is in control plane to actually create manifest for all the customer environments, right? Let's say that we had a new rule that will be generated for all the clusters, but the cluster need to have a specific infrastructure before we deploy that rule. Then we need to have a way to make sure that doesn't happen. To solve this, we do Docker in Docker in the Kustomize plugin. And let's see a quick snippet. So we use the config management plugin. And in there, we run a script which will start a Docker image that will be based on the customer version that is being deployed. And so thanks to that, we can make sure that every customer deployment will use the customized plugin that were made for that specific version. So what it means for us is that we can release new versions of the plugin without having any risks of regression on older environments. And we can also roll back clusters from newer versions to previous versions in case of an issue. One thing we noticed when we started to have reliable deployments is that we still got random failures, often due to transient issues with Argo CD or Argo Workflows. And so, yeah, we had to work around them. Those failures led to operator losing time trying to find the root cause, and often just a simple retry would fix them. So we found a bunch of error types. So like a service failing to start, getting to a crash loop, an Argo CD error, a plugin, a customized error causing the refresh to fail, stuck sync. Let's say you didn't have enough room in your cluster, so now you have pending pods, and so the Argo CD will try keeping to sync them and won't be able to do that. We also had some bugs in the watch loop between the workflow and the Argo CD sync, causing also the sync to spin. And usually when we have a sync that is not able to progress, then if you try to sync again, you will run into conflict with Argo CD complaining about a sync operation already in progress. So we get into this conflicting state, and for that, we just have to manually go and fix it. So to solve this, like we mentioned earlier, we built a small wrapper around the Argo CD CLI. Originally, it was just built to facilitate the user login, but we could reuse it to improve our deployment here. So the first thing we did was to sort the failures into two categories, so retryable failures and non-retryable failures. And so then we basically have, we identify all the failure types, and then we have our small CLI wrapper exit with a specific error code depending on the error type. And so if the error is retryable, then it sends a code to the workflow watching the sync, and then the workflow can just retry the step. If the failure is non-retryable, then the workflow can exit early and alert operators that they need to look at it. In addition to that, we also added better timeouts. So I don't know if you experienced it, but if Argo CD is stuck syncing a service that is not starting for any reason, it can sync forever, basically, until someone acts on it. And so in this case, our wrapper script has a configurable timeout value. And what we do is we watch which resource is being synced, and we increase the counter, and when we reach the amount of time we configure as timeout, we just exit with the terminal code, and the workflow exits as well. In that particular scenario, when we exit, we also will terminate the sync operation to make sure that we are not getting into this conflict state as well. And yeah, we also had a lot of other smaller issues, so I'll just list a few of them here. The Argo CD application controller is often in a crash group. It's usually when we run it at a really high load. The UI is very slow, and at the scale we operate at, it's basically not usable. The application status on the UI is often very misleading, so sometimes we sync an app, and as soon as it's synced, it's already out of sync. And as far as solutions, so for the Argo CD application controller, we often, unfortunately, just have to scale it. It's just often not able to handle the load, so we have to increase the scale. But we also have processes to keep it up to date and to quickly revert if something is wrong, and also to change the infrastructure, so the node types or count that is under it. That way we can improve it that way as well. For the UI, so we are waiting for the maintainers to release. So they are working on an improvement to have a server-side loading for the application list. So we are waiting on that. But in the meantime, we have a platform CLI that we use a lot, and all the service owners use. And basically, we expose a way through that CLI to for users to get to the application they want to look at. So if you want to look at the cluster for customer bay, you just have one command, and you can do that, and it opens the correct page. So you don't have to go through the application list. And for the misleading app statuses, so we had to fill the config map with a bunch of ignore resources values. But in the latest Argo CD versions, they added those as default, so we don't really have to do that anymore, so that's good news. Yeah, and so since we've been using it for many years at a really high scale, we also ran into a bunch of bugs, and we had the opportunity to fix a few. One example would be the application controller race condition. This was causing a lot of friction in our automation because when this bug happens, basically it's when the application controller restarts, it will lose track of the status of the applications it was watching. And so sometimes you have applications that it sees as being in sync while the sync actually completed. And that made any retry fail because the status were not matching. And so yeah, Kahou here found the race condition in the code. He submitted a PR which was merged and is part of Argo CD 3.1. Another one was due to the reconciliation cycle on resource updates on untracked resources. So for example, pods from cron jobs. And this will eat up a lot of CPU when we do the reconciliation. And so for this one, we submitted a new feature, so the ignore resource update annotation, to be able to manually filter out those resources.
Thanks, Jeremy. So recently, we update our Argo CD from 2.14 to 3.1, but we found a lot of interesting issues. So first of all, once we upgrade, we found the repo server just out of memory right away. And then with 3.1, it has a lot of new health check added. And we found a lot of transient error that caused our deployment pipeline slow down. And the last thing is that like we use sync wave, right? But we found a lot of like unexpected sync wave issue. So it turns out like that version, that issue is like on the AWS side, like always has the Kubernetes events out of order that cause the sync wave like problem. But we never found that on the Azure side, just on the AWS. So how do we mitigate that? So for the performance issue, basically we just scale out the repo server to have a more replica count and also like increase the upper limit. And for the health check, right, like thanks for the Argo CD override features. Currently, we just like override some of the upstream health check, and we are planning to push the change to upstream to fix those health check as well. And for the sync order issue, we just like increase the retry count in our control plane to just get it going. Okay, and that just concludes like, how we use Argo CD over the years. So let's move forward to like how we use Argo Workflow. So in the beginning of the talk, right, like we use control plane to drive our deployment pipeline. And I also mentioned that like we submit the workflow to drive the whole upgrade every day, right, like on all those like 2,000 customers. But actually, internally, it's not only one workflow, but it is a lot of workflow based on different situations. So you can view the control plane is just a giant state machine. And based on the state of the deployment, of each deployment, the control plane need to be smart enough to know like what workflow need to support. And also, another most important use case is that like, at a certain point of the deployment, right, the control plane need to put some guardrail on the deployment so that like it will avoid the operator to do some silly mistake and that causes some serious incidents. So with those like use case in mind, right, like when we first like try to come up like how to put guardrail, how to drive the state machine, the very early stage we thought that we just rely on the workflow object and just use the workflow status and drive the whole state machine. But turns out like it is not enough because the upstream workflow object only have like those pending, running, success, fail, and error state. Control plane need to know more like what's the inside of like what the deployment workflow is doing so that we can make better decisions during the operation. So how do we solve it? And then like the solution is quite simple. Is that like we just like inject the whole state transition into our workflow. So as you can see in here, like all those workflow, you see the blue circle in there, right? They are the state transition, our actual state machine of how the deployment runs. And how it works is that like let's say the deployment workflow, like let's say it goes from the create state to the info provision state and the service provisioning state. The control plane will just use the workflow API and constantly with the state output, with the Argo step work output. And then if the state got transit, right, it will just reflect back to the state object into the control plane. So let me give you some example how we use it. So on the left side, you see that the set workflow status, right? So it's a common state transition template that we use everywhere in our workflow. And you can see that like it's a pretty simple logic. The output is basically the input. But turns out it's also a very flexible and powerful way to do the state transition because like on the top right corner, let's say I want to like transit the deployment from the create state to the info provisioning state. I just put this step into our workflow. And then since our control plane has a channel open for that workflow object, you just constantly read like what the output it is. If we see the next state, right, we just update the state in our control plane database. So so far, like we talk about like how we scale the Kubernetes resources, how we use like Argo CD, Argo Workflow to handle like the operation at scale. But like at a certain point, we also need to scale the team, right? So so like for example, like this, like this is one of the workflow that we have, and we deploy this workflow daily around 200 times. And you can see that in here, it's at least like 50 steps in here, not including those skip already, right? So keep in mind, those workflow is not maintained by 2 or 3 people in one team. It's maintained by the whole platform group. And that comes to the question, like how do team A doesn't conflict with team B? And the solution is that like we will just like have the pattern such that like the main workflow will dynamically call the sub workflow logic depends on like what it is. So let's say like the main workflow will just do like all the day-to-day stuff like P5 check, Terraform pan and apply, spin up the Kubernetes cluster, and then I do the Argo CD sync. And then let's say like we to do the low downtime PostGrid upgrade, right? That is done like maybe like monthly or like twice a month, something like that. I don't want to like put those like 50 steps in this workflow, in the main workflow in here. So how do we do it? So the solution is that like we have the main workflow. The main workflow will do the template of like how we do the upgrade of the PostGrid upgrade like in here. And then all the actual logic of the upgrade will be handled by the database team in the sub-main workflow that will just like handle all the database upgrade. So this type of pattern, like you see it's pretty easy, but like we just want to make both workflow is really simple, and I want to make them really small so that like both workflow can be tested separately.
Thank you. Yeah, so we'll go over some examples of large workflows that we maintain. The first one is the red-black Kubernetes deployment with the Postgres blue-green updates. So it's a new addition, and now we do no downtime upgrade of both the Kubernetes version and the database for our clusters. If you are interested in learning more, we did a talk at last year's KubeCon, so it's on the CNCF YouTube channel if you want to look at it. So we do a bunch of periodic testing, like system test, integration test, chaos testing. We also have a bunch of CI, so for the GitHub status check, which will run like Terraform plans against fake infrastructure to make sure that any change is properly tested across all the types and scale of environments we have. We also do a lot of load tests. And so all of these workflows will have a lot of steps, and often we'll also have hundreds, sometimes, of parallel steps, which can be quite a lot. We also have a workflow orchestrator, which is basically a workflow that will test all these other workflows to make sure that we don't introduce regressions without when we release new features. And this all lead to another limitation of Argo workflows, which is with the UI and with the nodes for the workflow view. And so when we have hundreds of parallel steps, it's really easy to have hidden nodes. And often, for some reason, Argo will hide the nodes that you actually want to look at. So in that screenshot, you can see that the workflow is still running, but for some reason, the running node is not showed in that view. And so if you try to expand the view, then the UI will basically glitch out and be totally unusable. You can try to change the orientation, but it doesn't help. So what we try to do in those cases is that we don't do the workflow within workflow pattern, but we try to encourage people to do submit a child workflow from the main workflow and with the appropriate labels, so that way you can find your child workflow in the UI. So that makes users click a little bit more, but then the UI can be used. We also had a bunch of issues, mainly with the buttons in the UI that are hard to customize. So we found out the hard way that for the log archives, once upon a time it was just not working for us, and we needed the logs in an S3 bucket, but the button couldn't accept any other scheme than HTTP, so we had to direct the user to a README page instead, which is not really practical. Another button that is causing issue is the terminate button in the workflow page. So that one will just kill the workflow and don't go through any of the exit hooks. And we cannot have that happen on our workflows because so many of the automation relies on having workflow properly exiting. And so in that case, we just tell users to not click on it, but often they still will do it. So we actually had to release a Chrome plugin just to remove that button from the UI, because that's not something we could do in Argo at the time. I don't know if it's possible now, but yeah, and that's it. I think we have 2 minutes for questions. Thank you.
Any question? I can't hear. Like, can you come up?
You made it adopted Argo. You made a shift towards open source. So that represented a change in philosophy or risk?
I think it was more of an opportunity. So when we started working on the new platform, it was, I don't know, maybe 6-7 years ago. And at the time, we looked at the options, and Argo project was doing some really interesting things, which allowed us to very quickly iterate on the early days of the platform and to get to a working version. And once we were with them, then, yeah, we just kept using it and kept scaling with it. So it was just, yeah, opportunity to iterate faster at first. 6-7 years, yeah.
So what do you mean, like same way?
Testing apps, we do Apple apps. Because when we test like an Apple app, sync with
So we only have one app.
Okay.
Yeah. So we have the dedicated sync wave for different stuff, right? Like for example, we put the first couple sync wave to make sure the database migration run first, all the networking set up first, and then the service will come up, and after that we will some cleanup job, something like that. We don't have app of apps. We don't make it complicated. So one app will represent the whole cluster. That's it. And we only have one release, like every time. So yeah. I would like not to touch it. Just make sure that the release, like, I mean, like, our priority is make sure that like always keep the lights on, right? Like if it is like stable, I would not like to like change it. Like, but if something like we stuck, right? Like we push some change upstream, those things are really stuck. So that's why we need to push that. Otherwise, we will have trouble. Like the one that I found the race condition, even the script, it doesn't help. So that's why we automatically like just push the change upstream and then get it going. So yeah. But overall, like we are a lot more. We just want to like keep the lights on, keep the deployment going. We are not like, I want to something shiny to push upstream. We are not like that. So yeah. Hope this makes sense. So.